So, hello. My name is Alexei. And this, yeah. So schema is something I unfortunately adopted from someone else. So the thing is, once you start like fixing some things, you eventually become like a feature X guy somehow. Even though like you didn't create it, like you're just like putting up like small fires, but eventually like you become a de facto like schema guy. So currently like I'm a de facto schema guy. Although I don't have much to do with like anything really to do with original code, and it's mostly the original code still. And like with my in my experience with Cassandra and data stacks, etc., I realized that one way to stop being a feature X guy is to nuke the stuff from the orbit, rewrite it from scratch to its right, and basically so that nobody has to touch it again. So, yeah, so that's my plan for schema.
Make sure you don't comment it. Future-proof yourself. No high-level Java docs out there. And make sure there's no unit touch to it.
I do all that, right? So back in like the olden times, I think until 0.0, like schema used to be stored in XML file, like until 0.8, right? Until 0.7. And then eventually, like we moved to this, to schema tables and like to this protocol. So I'm gonna explain, like give an overview, like how schema works right now and how it doesn't, because I realize that many people actually don't realize like how exactly it works. So schema in Cassandra is stored in like system local tables. Before 3.0, it used to be system.schema column family, system.schema columns, like system.yada yada. In 3.0, we refactored it all. We have a new data dictionary. It's all in its own separate local key space called system schema. It's much it looks much nicer now. It's much easier to consume. Like all the whole names actually map like SQL syntax instead of all Swift params, and yeah, it's just much nicer. And on startup, Cassandra loads everything from disk and translates them into objects in memory, and all that lives in schema.instance. So how does schema actually propagate? So living in a local key space means that it doesn't use the normal write pass, normal read repair, normal streaming, like normal repair for its propagation. Like it's just local. So we have a special Cassandra schema specific write pass, where changes are still serialized as mutations, but we don't use the mutation verb. We just send the mutations for those schema tables to each of the node. It's irrelevant.
Yeah, it sounds like we were using that.
I will eventually, but yeah, never mind. It's all me. So on the write pass, a node that accepts the schema change, the schema altering statement, it does local validation for that change. So basically, if you create a table with some type, you make sure that the type exists, or you make sure that the table doesn't already exist. If you drop a type, you make sure that no table is currently using that. But all that validation is strictly local. And then the change gets turned into a mutation for a schema table, and that mutation is being propagated to all the nodes using the special pass. So that's the write pass. Now, as I said, there is no streaming involved, there is no actual repair. So what do we do if a node was absent during the schema change and then it comes up? How does it get to the change it missed? So for that, there is the other side. We gossip the digest of the current schema on each of the nodes. And if a node comes up, and sees that the digests on other nodes don't match its schema digest, it triggers a schema pull. And what that schema pull does is basically turns all the schema on that node that we're pulling from into a list of mutations. And when I say all, I mean like all of it. For all the key spaces, all the tables, all the columns, which can be huge, like in cases where like many tables. Like there is a ticket there, like a recent one right now, where that's actually causing OMs sometimes. Yeah. I'm kidding you not. That's actually an issue. Yeah. So that can happen sometimes. Yeah. So that's basically it. So it detects this mismatch digest. It converts everything to mutations and it streams them. But you can't actually. So yeah. Let me talk about the problems with it. So one of the problems is actual validation. As I said, it's performed locally on the node. That's handling the schema change and then streamed forward. But it means you can have funky race conditions there. So the most common one and the most obvious one is relatively new. Well, and when I say relatively new, I mean like 2.1, which is like most people are just moving to, I heard. And that change was Cassandra 5202, which was a huge thing. It fixed a long-standing issue that we had. But it kind of revealed issues with the schema mechanism. So each table has a unique CFID to it. And before 2.1, it used to be deterministically generated from key space name and table name. So they always converged. But now we use a dummy UID. So if you have a two-node cluster, for example, and you do a create table on both of them at the same time, then they will come up with different CFIDs, obviously, unless your UIDs somehow match and collide, which never happens. But that's an issue. That's an issue. So validation passes on both nodes, and then those mutations get propagated like to both of the nodes. And when they try to reconcile it, you get a column family ID mismatch. And that's something that's kind of common recently. And those next pages are also real and true. Like it's a big deal. Like it comes up often on IRC. It comes up often on the mailing list and in Jira tickets. So that's a big deal. But it's not like the only example where this can happen. Like imagine that on one node you're dropping a type which isn't used by anything at the moment, and on the other node you're creating a table that's using that type. And both validations pass, but then mutation gets propagated. And one node has a table that's using a non-existing type. And in 3.0, you just won't be able to load that schema anymore, which is kind of bad. Or if you have a two views and you create an NV on one node, and on the other node somehow you drop the base table, and when they reconcile, you're also not going to be happy. So that's a problem. It wasn't a big problem before CQL, I would say, but now it is. So what are the problems that we have here? The other problem is that for various reasons, because of this coupling, like tight coupling between like schema tables and the mechanism of propagation, we can't really change, like add new things in non-major releases, and that's a problem. So we have several tickets right now that we just can't commit to 3.x. Because there is no good way to modify schema table of life, you know. Especially now after 1899, if you push a mutation to a node that's not aware of a new column, it will just fail the whole mutation. So because of this, like between 1.2 and 2.0, that's inconvenient. We introduced a barrier. which is like you don't push schema mutations to nodes that have a different messaging version, and you don't pull them either. And that was ticket. Yeah, that was a very descriptive description. I guess, as many of our tickets do, and yeah. So this is an issue for upgrades. Like one of my other pet peeves was making upgrades in general like a I wouldn't say a non-event because it will always be a huge event, but it's something that the application should not notice, right? Like it just shouldn't. Like none of these operations, like you don't have to have special logic that, for example, like doesn't do repair while you do upgrades or doesn't do any schema changes while you do upgrade. Like that should be just invisible to whoever is consuming this effort. But now with schema changes, like you can't do that. Like if you have a node that's upgrading from 2.1 to 3.0, until the cluster is upgraded, like you can't really do schema changes. They will not propagate. And to me, it's a big deal. So yeah, so these are the two basic issues that I see. Oh, three issues. One of them is validation and schema like application does not serialize, so you can have these funky race conditions that are true in schema. Oh, by the way, like it's actually even worse. You know, it is possible to mess up schema in just a single node cluster with a single client with just 2 driver sessions. So there are a couple of statements where like you can do like where validation is racing between 2 threads at the validation, and then application itself is serialized, but the validation is not repeated. So you can wrap a single node with a single client if you try hard. It doesn't come up often. Yeah, second issue is inability to do schema changes during an upgrade. And the third issue is like general inefficiency of it all. Like you shouldn't be streaming all of your schema on digest mismatch. Like for some people it's a big deal and it can lead to OS. It's big. So how do I think we can fix it? Like the actual fix is actually pretty straightforward in general. Basically all you need to make sure that within a single key space, all the updates to it are serialized. That's about it. So what we're gonna do most likely in 4.0, unfortunately, so for most of you it's like 2030s. In 4.0 is we're gonna use Paxos for propagation, but not Paxos is like Paxos is the algorithm, not the current code path that we do. So code-wise, we're gonna have a mutable schema on all nodes. So this is an example I had like images from like last year. So for an altered key space statement. So basically you have an immutable schema snapshot instance like on each of the nodes with a single atomic reference to it that gets swapped. It makes all your statements like nicely testable because like you can just test it, test the transformation. And what you do next is you serialize that transformation, but you no longer use a schema table mutation to do this. Like what you do is like with a custom protocol, you have a version serialization of a schema change, which you can extend and you can still push it to older nodes using older serialization version. And the other thing you can do is you can actually change them. So you can batch schema changes for a single key space. Like you just chain transforms. And what you do to apply is essentially an equivalent of doing a cast update, which is like update key space, apply this change if and set generation equals generation +1 if current generation is this. Yeah. So what you do, each key space has its current schema generation. You serialize changes like in a proper version format, and you do an equivalent of that as a cast update. Like it's actually pretty trivial. And to avoid, it's 15 minutes. Yeah, and for pool, like to make it like completely transparent, like instead of gossiping a single like schema digest, you have a map of version to digest. So like if you're in a mixed mode cluster, say like 3.0 plus 4.0, like as a 3.0 node, you can look up at the 3.0 version of the digest of the 4.0 node, and if they match, like you're okay. Yeah. So to sum it up, this will be fixed in 4.0. And what you should do right now is basically be very careful with certain schema changes. Like it's safe to update like stuff like GC trace second, compression params, compaction params, because those do converge. But for things like 3D table, for things that have like interdependent entities, like types and tables, or like functions and aggregates, you have to make sure that you only have a single process at all times during those changes. Basically, Cassandra is not serializing those, but you should be. Just something to be aware of because it like wrecks some people. And some people just rely on have automated systems that reply like schema changes, like schemas, like using like if not exists, for example, and it's very misguiding. Like you could guess that like maybe okay, it's using like if not exists, maybe like it's like a gas, you know, it's atomic. No, it isn't. Like if not exists, like the only thing if not exists means it will throw an exception if it already exists. Like that's what if not exists does. It just throws exceptions. Swallows. Yeah, it just swallows exceptions. Swallows. Yeah, so that's basically it. Be very careful about those changes and wait until 4.0. The Jira to follow would be Cassandra 10699. And
wait, what is that code in? What is that code in?
It swallows the exception.
So wait, so if it exists, but then you check that it doesn't exist, but why would it be thrown if it exists?
So so this is create if not exists. It tries to announce, but if it already exists and you had a flag if not exists, it will just return null. I mean, it just swallows, and it's the same with drop table if exists. It just swallows exceptions. Like it has no extra atomicity, no extra serialization. Yeah, that's about it actually.
So, so basically, if you go to Paxos, you're not going to be able to change your schema if you want to form.
Yeah, but it's not going to be like a global quorum. So you map key space name to a token, and you'll have like a replica set. Like say, like you'll have a virtual ref of 3. You'll get a quorum there. That's the success. You propagate the change everywhere. And for actual dissemination, like for pools, I'm not sure like it has to be done yet. But something we can do is to use Merkle trees, like an equivalent of Merkle trees for pools, so that if you have a mismatched digest, you just get a tree of like digests per key space list, and only pull those like things that mismatch. And I think like it's an answer for those like OM-like problems for like huge schema nodes for huge schema clusters. Yeah, now this is all. Thank you.
Lunch is in the Victorian room.